Welcome, and now we finally have the ability to talk about the derivative of a function at a number, not of a general function yet, but when we talk about derivative of a function, you can see the definition on the screen, and so it's defined as a limit, which we actually saw this earlier, right? And so this is another way to express this expression here. It's another way to express our average rate of change. So then what we're doing is to find the instantaneous rate of change. Again, the instantaneous rate of change is given by this limit. We have to do limit as h approaches 0 of the average rate of change. So make that average rate of change over a smaller and smaller interval until it's effectively just one single point. But so the whole right side, so the derivative at a number is an instantaneous, I'll just write IROC, that's easier, instantaneous rate of change, and then the the right hand side is the limit of an average rate of change. There we go. And then the only thing to note here is that the limit has to exist, and then you can say you have a derivative of a function at a number. Okay, and we already did the follow-up, so I'm not even going to bother. So let's get some practice with this. So it says compute the derivative of the function at that point, right? And so what I need to do according to the definition, okay, so I need f prime at 1, right? That is going to equal limit as h approaches 0, and I'm just kind of following the definition of, let's see, there's numerator, denominator. This is going to be f of 1 plus h minus f of 1 all over h. Okay, and limit as h goes to 0. And then in the numerator, I'm going to have 1 plus h cubed plus 1 plus h. And then if I substitute in 1 into the original function, I get 3. And then this is all over h, okay? And now I have to just go through the algebra. Limit, h goes to 0, and then fast expanding this is going to be 2 plus 6h plus 6h squared plus 2h cubed, and then plus 1 plus h minus 3. Okay, all over h. And so then if I reduce, right, the 1 and 2 will cancel with the 3, and then the h's will combine. Okay, so then I'll have limit as h goes to 0, and then h, and then there will be a 7. Let's see, I'm going to try to factor out an h. 7 from the 7h, and then I'll have still plus a 6h squared, right, but then I factor it out, so it'd be just 6h, and then plus 2h squared, again, I factor out an h. Okay, so then those h's can reduce, and I would end up with one more limit, and then I can finish it off. 7 plus 6 plus 6h plus 2h squared. Send h to 0. This is a continuous function, so I can just substitute this in, and I will get a whopping 7. So what this 7 is telling me is it is the instantaneous rate of change of the function at 1, which is also the slope of the tangent line. So with this, I could perhaps construct a tangent line at 1 for this function. So there you go. We have now an understanding of what the derivative of a function at a number means.